Very good evening guys. Today we are going to see few of the problems with differential manometer. So in the previous video we saw how to derive an equation for finding out the pressure difference between the two different pipes in a differential U-tube manometer. So in relation to that we are going to see a problem. So here is your problem. A differential manometer is connected at 2 points A and B of the two pipes as shown in the figure. So in the question itself they have given you the diagram also. And here they have given the pipe A contains a liquid of specific gravity 0.5. So here what is the specific gravity of the liquid? It is 1.5. While the pipe B contains a liquid of specific gravity 0.9. Okay, so the pressure at A and B is also given. That is, the pressure at A is 1 kgf per centimeter square and the pressure at B is PB is 1.8 kgf per centimeter square respectively. Find the difference in mercury level in this differential manometer. So this is the question that is asked you. So this is a diagram what is given in the question itself. So what is here, from this you will be able to understand this is a differential manometer, that is we are going to find out the pressure difference between two pipes. Okay, and see here how the level of pipes, these pipes are not at same level, they are at different levels. So here we have to find out what is the pressure difference between these two pipes. So how will you do this here? We normally will be finding out the pressure difference, but here they have asked you to find out the difference in mercury level in the differential manometer. That is not the pressure difference. Why? Because the pressure is given here, PA is also given and PB is also given. Normally we used to find out only PA and PB or PA minus PB, that is differential manometer. Na? So we will be finding out the difference of pressures. But here they ask you to find out what is the difference in the mercury level. What is the difference in mercury level means what is that? It is the height. Okay, so the h is unknown. So that is they have given in the problem itself. So what is given here? So the pressure at A is given. It is 1 kgf per centimeter square. See, I already told you that whenever the pressure is there, please convert that in terms of Newton as well as meter. So what is 1 kgf is? 1 kgf is 9.81 Newton. And how will you convert 1 centimeter square into meter square? It is 10 power minus 4 meter square. Or if you are coming in denomination, it will be, that is 1 kgf divided by 10 power minus 4 meter square. Since it is division by division, we are taking that to the numerator. So here what is the answer will be 10 to the power of 4 for conversion of centimeter square into meter square. And apart from that, for the conversion of kgf into Newton, we are multiplying with 9.81. So what is the unit now? It is Newton per meter square. So we know what is PA. And similarly, we have to know what is S1. What is S1? It is a specific gravity of the fluid at this point A. Okay, so let this be S1. Specific gravity is given here. How much it is? 1.5. But specific gravity is not there in the pressure. Usually the pressure formula will consist of rho GH. Okay, that is your pressure formula. So what is rho? Rho is density. G is acceleration due to gravity. It is always a constant and it's 9.81 meter per second square. H is unknown here, so we need not bother about it. So rho is density we required. So how do you find out density? We already knows that density is equal to, or we can say density of any liquid divided by the density of standard liquid is your specific gravity. Am I right? So it may be either in terms of mass density or it may be in terms of weight density. So rho is density of a liquid by density of the standard liquid. So standard liquid here is only water. So here we know what is a specific gravity. So specific gravity is S1. So S is equal to density of liquid by density of the standard liquid. Okay. So here what is the value of S? We are taking it as 1.5. We don't know the density of liquid. So let it be rho 1. Divide by density of standard water. We already know it is 1000 kg per meter cube. So what is the value of rho 1? It is 1000 into 1.5 kg per meter cube. Okay, so we know the density of the fluid at the point A. So that is 1000 into 1.5 kg per meter cube. Okay, so here also we have got the pressure. Now we are going to find out what is the, we have got the density. Now we are going to find out what is the density of the case S2. So S2 is the specific gravity of the fluid in pipe B. Okay, so here its specific gravity is 0.9. So the same formula, by using the same formula, you are going to find out what is rho 2. So rho 2 is equal to density of the liquid by density of a standard water is equal to a specific gravity. So use the same formula. So what is that? Rho 1 is 1000 into specific gravity. Similarly, rho 2 is equal to 1000 into specific gravity of the liquid, that is 0.9. So it is 900 kg per meter cube. So now one more liquid we have, that is your mercury. So what is the specific gravity of mercury? It is not given in the question, but we have to know that the specific gravity of the mercury is always 13.6. So what is the density of mercury if you want to know? Specific gravity of mercury is 13.6. Therefore, density of mercury is 13.6 into 1000. Okay, so it is 13600 kg per meter cube. So what are the things we know? We have known rho, rho 1, rho 2, rho m. So which are all essential for this formula. Okay, so rho is essential, G is essential. So P alone we have to find it out. And P here we have given in terms of Newton per meter square. Similarly, we have to find out what is the value of PB in terms of Newton per meter square. So what is PB? PB is equal to 1.8 kgf per centimeter square. So please convert into Newton per centimeter square. So 1.8 conversion of kgf into Newton is 9.81 into 10 to the power 4. Why? To convert of centimeter square in division or in denominator to that of the numerator. Okay. So it will be 10 to the power minus 4. When it comes to the numerator, it will become 10 to the power 4. So what is the unit of this? Newton per meter square. Now we are going to find out what is the pressure intensity in the left limb and what is the pressure intensity in the right limb. Why? At equilibrium, we know that in the datum line, that is at the horizontal line, the pressure will be same in both right limb as well as in the left limb. Okay, so in the left limb and right limb, the pressure will be the same. So here in this case, what we have to find out? First, we will formulate the pressure intensity in the left limb. Okay, so pressure intensity in the left limb. So in case of pressure intensity in the left limb, what are the pressures we have? One is PA, that is the pressure, and in addition to that, we have the pressure because of this liquid, and this liquid is acting at a height of this much. That is from the center of the pipeline till the datum line is always the liquid level. Okay. So what is the formula we have? Rho, and since this one is as 1, we are considering as rho 1 G into, instead of H, we are taking this as 3 plus 2. Okay, so this is the height till which this liquid is flowing. So 3 plus 2. Am I right? It is rho 1 into G into 3 plus 2. Okay, now we will go for the other thing, that is your mercury. This is also in the left limb. So it is acting at the height of H. Okay, so plus, what is the mercury? It is rho m into G into, what is it? Height is H. Okay, so that is the pressure intensity in the left limb. Just we are substituting the value. So what is the value of the PA here? It is 9.81 into 10 to the power 4. Am I right? Plus, what is the value of rho 1 here? It is 1.5 into 1000 into G is 9.81 into 3 plus 2 plus rho m is your density of mercury. So density of mercury is how much? 13.6 into 1000 into G is 9.81 and H is unknown. So this be the equation number 1. Okay, what is that? You got it? 13.6 into 1000 into 9.81 into H is because of mercury, plus the 1.5 into 1000 into 9.81 into 2 plus 3, that is because of this liquid in the pipe A, and other one is the pressure at pipe A. Similarly, we have to calculate what is the pressure intensity in the right limb. So in the right limb also we have a fluid. Sorry. So this fluid is at a height of this much. That is 2 meters plus h meters. So now we are going to find out what is the pressure intensity in the right limb. Am I right? So in case of right limb, so the pressure is because of two cases. One is because of this liquid. That is, we are considering that as rho 1 or rho 2. Here we are considering this as 2 and this we are considering as 1. Am I right? And apart from that, if we have mercury, we will be having the mercury. Okay. But here in this case, we don't have mercury. Only we have the pressure at B and only this liquid. Okay. So what is the pressure intensity at the right limb is PB. That is pressure here at this point B. And because of this liquid, what is the pressure? So because of the liquid, what is the pressure is rho 2 because it is the density of the liquid at this point into G into H. H here is 2 plus H. Am I right? That is the total height the liquid is flows. So what I am doing is I am going to substitute the value here. So PB we have got it already. It is 1.8 into 9.81 into 10 to the power of 4. Okay. Plus rho 2 is how much? Rho 2 is 900 into G is 9.81 into 2 plus H. So this is the equation number 2. So what is that is? You have to at horizontal, that is at the datum line we know that, or at equilibrium we know that the pressure intensity at the left limb will be equal to the pressure intensity in the right limb. Okay. So here we are giving at equilibrium. Okay, we are equating equation 1 is equal to equation 2. That is pressure in the left limb is equal to pressure in the right limb. So here what is the equation you got here? 9.81 into 10 to the power 4 plus 1.5 into 1000 into 9.81 into 3 plus 2. Just I am rewriting this plus 13.6 into 1000 into 9.81 into H. Am I right? So into 9.81 into H. So this is my equation in the left limb. So that is equal to the equation in the right limb. So what is the equation in that case of right limb? It is 1.8 into 9.81 into 10 to the power of 4. Okay. Plus 900 into 9.81 into 2 plus H. Am I right? So this is the equation. What we are getting in the right limb. So when we equate this two, we could observe that here 9.81 is in every equation and 1000 is also there in almost in every equation. So we are dividing entirely by 1000 into 9.81. So when we divide this, we will be getting a small equation, that is, we will be getting up as 13.6H plus 7.5 plus 10, that is equal to H plus 2 into 0.9 plus 18. Okay. So how we are getting here? In this case we got 2 plus 3 only. So only 1 here we have an H. So here we have 2 plus H. So when we are replacing it up, when we are multiplying this 13.6 into 1000 into 9.81 into H's, when we are dividing here, this 1000 and this 9.81 will go. So we will get only 13.6 H. Okay. Similarly, when you come to this 1.5 into 1000 into this will be get cancelled. So 3 plus 2 is 5. 5 into 1.5 is 7.5. Okay. So and when we come here, this 9.81 into 10 to the power of 4 is get cancelled. And here instead of 10 to the power of 4, we have to cancel by 10 to the power of 3. So we will have 1 10. So that is equal to this, in this case 2 plus H and H plus 2 are same. Okay, H plus 2. Here we have 900 into 9.81. So when it get cancelled, we will get only 0.9. And this case it will be getting as 18. Okay. So this is the equation when we get solved it. So how will you get solved once again? So 13.6 H plus 10 plus 7.5 is 17.5. That is equal to H plus 2 Or we can multiply here like this. It is 0.9H plus 9 2s are 18. It is 1.8 plus 18. Am I right? So here what is the value of H? Just we are rearranging these two equations and we are solving it up. So when we solve this, it is coming H is equal to 2.3 divided by 12.7. Okay, so that is equal to 0.181 meters, or we can say that it is 18.1 centimeters. Clear? So this is the problem where we have worked out with a differential manometer. So these two differential manometers are at different levels. So how we have found out what is in this question they didn't ask you the find out the pressure difference. Instead they have asked you to find out the difference in the mercury level. That is the height is asked in the diagram itself they have given in the question. So only thing is we are equating the pressure in the left limb, that is equal to the equating the pressure in the right limb. Okay. Just by solving that we have got the value of your H. That H is 18.1 centimeters. Is it clear guys? So we will go for the next problem now. Yes guys, we will go for the second problem now. So this is your second problem where this is also a differential manometer which is connecting to the 2 points A and B, and in this question also the figure is given to you. Okay, so you need not sketch out the figure here also. So at B the air pressure is given 9.81 Newton per centimeter square. Absolute. Why it is given as absolute here? Because it is been open to the atmosphere, so it is being connected with it of your air. Okay, so they asked you to find out what is the absolute pressure at A. Find out the absolute pressure at A, because this absolute pressure at B is given. So they ask you to find out what is the absolute pressure at A. So what is that? PB is given here. So PB is 9.81 Newton per centimeter square. So what is asked here? PA is asked. So all of the details are given in the question. So that is the height of the liquid of your mercury as well as the liquid of oil, because in one pipe we have oil and in the other pipe we have water. Okay, so this that specific gravity and what is the density is known. Density of mercury is known and the height is also known, and pressure of one pipe is also known. So only thing is you have to find out what is the pressure at the second pipe. Okay, so first one is main thing is first you have to find out the given details. What are the things given? Why? Because we have to convert into the appropriate units. Okay, so they have given here the PB. So what is the PB value is 9.81 Newton per centimeter square. But what we want is a Newton per meter square. So it is 9.81. Just now we have seen how the conversion we have to make it up. So into the 10 to the power of Newton per meter square. So we know what is the pressure at B. Okay. Similarly, what is that is, you have to know this heights. Okay. So the height of this liquid in the left limb is 20 centimeters. Say I am saying that as H1. So H1 is 20 centimeter. I don't want it to centimeter. It has to be in terms of meter. So 1 centimeter is equal to how much meter? It is 10 to the power of minus 2 meters. Okay. So it is 20 into 10 to the power of minus 2 meters, or we can say it is 0.2 meters. Okay. Similarly, what is the height of the liquid in the limb 2? That is your right limb. So let this be H2. Okay. So this is your H1. And this is your H1, that is your mercury. Okay. So height of the liquid in the right limb will be 60 centimeter. So that is 60 into 10 to the power minus 2. Once again it is 0.6 meters. Okay. So what is H1? Once again we are converting the height of the mercury level, that is 10 centimeters. I am going to convert it as 10 into 10 power minus 2. Okay, the same as it is 0.1 meters. So we have converted all these equations. Now what is given? Specific gravity of the liquid is given. So specific gravity of oil is given 0.9. Automatically we know what is the density. Density is equal to specific gravity of the oil into 1000. 1000 is the density of your standard fluid. So it is 0.9 into 1000 kg per meter cube. Am I right? And but in the right hand side we need not, because it is given as water. So in case of water we know the density directly, it is 1000 kg per meter cube. Okay, so need not do with the specific gravity. So then third case is your specific gravity of your mercury, say Sm. Sm is 13.6. So which shows that what is rho m? Density of mercury is 13.6 into 1000 that is 13600 kg per meter cube. So now we have converted everything into the relevant units. Now what is our thing is usually at a datum line, that is where the datum line is horizontal now. So at this datum line XX, or we can say that at equilibrium the pressure in the left limb will be equal to that of the pressure in the right limb. Okay. So first we will find out what is the pressure in the left limb. So when you go to the solution, find out what is the pressure intensity in left limb. So what is the pressures we have here? One is the pressure, unknown pressure PA, that is unknown, plus the pressure because of this liquid, and this liquid is acting to the height of 20 centimeter. Usually we will be having as rho 1 G H1. H1 here is 20 centimeters. We have converted into meters. It is 0.2 meters. Okay, plus here we have mercury. So what is it mercury? Rho mg into Hm. We have converted that also into meters. So it is 0.1 meters. Okay. So that are the pressure intensity in the left limb. So we are just substituting the value Pa plus what is the value of rho 1 we have got here? Rho 1 is 0.9. So this is here plus 0.9 into 1000 into 0.2. Right. Plus rho m is your density of your mercury. So it is 13.6 into 1000 we can write it out, or if you have, we can write it directly 13,600. Okay. Into G is 9.81. It is always constant. See here we have missed out the value of G. So that G also we have to be included. Okay. So it is 9.81 into 0.2 plus 13.6 into 1000 is for rho m into G is 9.81 into 0.1. Now we have got this equation. So let this equation be equation number 1. Similarly, we have to find out what is the pressure intensity in the right limb. So what is the pressure intensity in the case of right limb? What are the two liquids that is there in the right limb? One is the water and other one is the mercury. Okay, and PB is also given here. So I am just writing the general equation first. So the PB is the pressure here because of this water. Sorry. This is the PB is the pressure because of water. And we know this liquid height. This liquid height is 60 centimeters. So this is your water pressure because of this height level. Okay. So it is rho 2 into G into 60 centimeter is the total height. It is up to the datum line. Okay. So that also you have to check it up. So 0.6. Okay. And any other liquid do we have in the right limb? No. Because mercury is below the datum line. Only these two things are above the datum lines. Okay. So just I am substituting the value of PB. Already we have converted that. It is 9.81 into 10 to the power of 4. Okay. Plus rho 2 is we have got here. It is 1000. And G is always 9.81 into 0.6. Okay. So let this be equation number 2. So what is our concept is? At XX, that is at datum line, we have to find out the pressure in the left limb is equal to the pressure in the right limb. Okay. So I am just writing this at equilibrium, or we can say at XX datum line, pressure in left limb is equal to the pressure in right limb. Am I right? So here we have already got that pressure equation. So just I am rubbing off this so that we will get a full equation here. So PA plus 0.9 into 1000 into 9.81 into 0.2 plus 13.6 into 1000 into 9.81 into 0.1. That is equal to, here the pressure at right limb 9.81 into 10 to the power 4 plus 1000 into 9.81 into 0.6. Okay. So here what we are doing it up, we have equated the two different in pressures. Now when we solve this, what you get it up is 103986, that is equal to 13341.6 plus 1765.8 plus PA. So I am taking this to the side. So it is 103986 is equal to 13341.6 plus 1765.8 plus PA. Just use your calculators, you will be able to derive it up. Okay. So what is the absolute pressure at A? So absolute pressure at A, that is PA, we have to find it out. So just bring it up all the equations to one hand side, that is to the left side, so that you will be able to find out what is the value of PA. And what are the unit comes, please convert in terms of 11th of Newton per centimeter square. Okay, so what will be your final answer? It is 8.887 Newton per centimeter square. Is it clear, guys? So here what we have did is we have seen the second problem. So in the second problem, we have seen one more differential manometer. In the previous problem, what we saw, we have found out the difference in the mercury level. Am I right? So now we have seen what is the pressure in the absolute pressure in the level. I mean the pipe A. Okay. So we will go for the next problem now. Yes, guys. So we will go for the third problem here. So a pipe contains an oil of specific gravity 0.9. A differential manometer is connected at the 2 points A and B that shows a difference in mercury level as 15 centimeter. So what is the specific gravity of the oil is given? Specific gravity of the oil is given as 0.9. So we don't know what is the density. Density is 0.9 into 1000 kg per meter cube. Finish it up there itself. Okay. So here what is the difference in mercury level is given. Difference in mercury level is usually given by the term H. It is 15 centimeter. We have to convert that into meters. So 15 into 10 to the power of minus 2 meters. Okay, what is they asked you? Find the difference of pressure itself they have asked you. So need not sketch out this, nothing, they didn't give you any height or anything. So they asked you to find out the difference at the 2 points. Since it is given as differential manometer. So what is the difference of pressure at 2 points? It is PA minus PB. So they asked you to find out what is PA minus PB. Okay. So what is the formula for PA minus PB? In the previous video we have derived it. Okay. What is that is PA minus PB is equal to GH, that is rho GH na. So GH into rho G minus rho 1. Okay. Here what is rho G? Rho G is your mercury. Okay. So rho G, we know what is rho G. Specific gravity of mercury is 13.6. So rho G is 13.6 into 1000 kg per meter cube. Am I right? So this mere substitution of the values here, nothing is there. So G is 9.81 meter per, you know that it is meter cube per second, into H is 15 into 10 to the power minus 2 meters, into rho G is 13.6 into 1000, that is 13,600, minus rho 1 is 0.9 into 1000, that is 900 kg per meter cube. Okay. So just we can solve this up. We will be able to find out the answer of the pressure difference. So PA minus PB. So what is the answer here? It is 18688 Newton per meter square. Why? Because here the pressures we have given in terms of, okay, Newton, it is in terms of kg per meter cube. Okay, so both the, density is in terms of kg per meter cube. So this equation itself will be in terms of Newton per meter square. Okay, so the final answer here we have got is PA minus PB is equal to 18,688 Newton per meter square. Okay, guys. So this is a very simplest problem, but usually we'll have a big problem in which the sketches we have to draw it up and we have to find out the solution. Okay, so here now we will go for the next type of differential manometer. So far we have seen is a differential manometer where it is going to measure the pressure difference between the two pipes, whether it may be at same level or at different levels. Am I right? So what is the next type of differential manometer is inverted U-tube manometer. Okay, so here we will go to see the derivation, how this inverted U-tube manometer, how we will find out the pressure difference. So this is also a differential manometer only. So here we are going to see about inverted U-tube manometer. That too very specifically we can say inverted U-tube differential manometer, because it's going to find out the pressure difference between the two pipes. Am I here? So what is that is, for our simplicity we are converting, we are considering that these two pipes are at same levels. Okay, but what is that is, it is inverted. How it is been here? It is inverted. That is why it is called as inverted U-tube manometers. So what is the use of this inverted U-tube manometer is, if we want to find out the very low pressures, or we can say vacuum pressures, in such cases we will be going for this inverted U-tube manometer. Okay, so this is very useful for finding out the difference of low pressures. Okay, so here this datum line is, as usual we used to draw now, it is XX. Okay, so this is your point A, this is your point B. Okay, so all other things will be the same. How what we do here is, so consider here this pressure is more compared to the pressure here. So what happens here, the mercury will fall down from here to here. Okay, it will be moving like this. So just I am showing the mercury by this symbol. So this is your mercury. Now we have two liquids here. One is in the pipe A. So let this height be H1. From the center of the pipe, let this be H1. Okay. And similarly here this will be having the next liquid in the pipe B. Okay. So let this height be H2. So we have given H1 and H2. And what is this height? This is B, let this be H. It's the height of your mercury. Similarly, here we will be having S1, rho 1. Okay, it is the density as well as the specific gravity in pipe A. And here we have S2, rho 2. So, whenever such derivations are given, you have to write all the specifications. That is, let. Okay, H1 is the height of liquid level from the center of the pipe A in left limb to datum line XX. Okay, second, similarly H2 is the height of the liquid, okay, from the center of the pipe in right limb, but it is not to the datum, here it is to that of the mercury level, okay, to mercury level. And what is H? H is the height of the liquid or height of mercury. Okay, it's from that of your datum. From datum XX. So we know this. Okay, and we know what is S1. S1 is the specific gravity of liquid in pipe A. Am I right? Similarly, S2 is the specific gravity of liquid in pipe B. And SM, or we can have it as SG, whatever we could, will be give it up. SG is the specific gravity of mercury. Similarly, what is rho 1? Rho 1 is the density of liquid at pipe A. Similarly, rho 2 is density of liquid at pipe B. Okay. And similarly, rho G is the density of mercury. I think we have given all the names. And apart from that, we have to give, this is PA, this is the PB. So, pressure in the pipe A as well as what is the pressure in the pipe B. Now, we will go for this equation. So, what we have to do after writing all this nomenclature, we have to go for the pressure intensity under pipe. So, here we will be seeing one major difference between the other manometer while writing the equation and this. I already told you that we have to understand the concept and then we have to write. Okay. As such, we should not mug up this equations because it will not helpful to us for any time. Okay. So here what is that is I am going to find out what is the pressure intensity in the left limb. Please listen carefully. Why? Because it is not the case in the previous time. This is a different case because it is a inverted U-tube manometer. So what is the pressure intensity in the left limb? As usual, the unknown pressure is PA. So I am taking it as PA. Well and good. Now, what is the pressure here because of this liquid? Usually the pressure will be given as rho GH, and here the element density is rho 1 and H is H1. So you will get rho 1 GH1. Good. But here we have to give the symbol of negative. In the previous problems, in the previous derivations, we have symbol of positive because it is U-tube manometer, and here it is inverted U-tube manometer. So here the pressure is given in terms of negative. Okay. So that's all in this left limb. Am I right? So let this be equation number 1. Next is pressure intensity in the right limb. So what is the pressure intensity in the right limb we have? It is because of two liquids. One is your mercury and other one is the liquid at B. Okay. So we can have it as once again PB. PB is the pressure here minus. This is very important here. So and because of this liquid what you get is rho 2G H2 minus because of mercury rho G G H. Rho G is your density of mercury we have seen. Okay. So this is the same case. All other things are same. Only thing is we have to be very careful in case of inverted manometers where we have the symbol of negative. Okay. So at XX the same case, or we can say at equilibrium, both are same at equilibrium. The pressure in left limb is equal to the pressure in the right limb. So we have to write that statement. So pressure in left limb is equal to pressure in the right limb. So just we are going to equate these two. Am I right? So what is the pressure in the left limb? It is PA minus rho 1G H1. That is equal to PB minus rho 2G H2 minus rho G GH. Okay, so we have got the equation. Now we are going to rearrange it up and we are going to simplify it up. Okay, so it is PA minus PB. I am bringing this to this side. So it will be, when you go to this side, it will be rho 1 GH1 minus rho 2 GH2 minus rho G GH. Am I right? So this is the equation for your inverted U-tube manometers. Is it clear, guys? So in the next video, we will be seeing few of the problems with this inverted U-tube manometer. Thank you, guys.